This video provides an introduction to another technique for solving quadratic equations called completing the square. Since the square root property is a pretty easy way to solve quadratic equations, we sometimes manipulate equations into a form where the square root property can be applied. This form we want to get to is a perfect square trinomial equal to a constant. A perfect square trinomial is a trinomial that factors into a binomial squared. And a binomial squared would look like x plus or minus a number raised to the second power. So binomial, two terms, and then all that squared. Let's start by discussing how to create a perfect square trinomial. Let's consider x squared plus 8x. To the right is a geometric representation of the expression. The area of this shape is x squared plus 8x. So if we take a look at the side of this big square, since its area is x squared, and we know that a square, the sides are the same, these are each going to measure x, giving that big square an area of x squared. For either of the rectangles labeled 4x, it shares a side with our square, so we know the top of this rectangle is x. Similarly, the side of this rectangle shares a side with our square, so we know that this here is also x. If the area of this rectangle is 4x, and we know that the top side is x, that makes the short side equal to just 4. And that's true for both of these rectangles having area of 4x. We want to find the area of the missing square so that we can represent the area of the completed square as a perfect square trinomial. So we want to find this area right here. It shares the short side of both of the rectangles having area of 4x. So it's going to make this side 4 and this side also 4, giving the shaded square an area of 16. Therefore, if we added 16 to x squared plus 8x, I would have this completed square. Yeah, look at the big square. I would now have a completed square. The side of this completed square on the left is going to be x plus 4, and the side of the completed square on the bottom is also x plus 4. Therefore, we could say the area of this completed square is x plus 4 times x plus 4, or x plus 4 squared. We've completed the big square, creating a perfect square trinomial, x squared plus 8x plus 16, which can then factor into a binomial squared, x plus 4 squared. Now, of course, we don't want to draw out a picture like that every time we want to complete the square, so we have a general rule for finding the last term to create a perfect square trinomial. Given x squared plus bx, the perfect square trinomial is x squared plus bx plus b divided by 2 squared. And you'll notice if we take our b value, which is 8, we take 8, divide it by 2, and square it, that's going to be 4 squared, which is 16, which is exactly the number we got from our diagram. So let's practice finding the last term to create a perfect square trinomial. That's going to be adding b divided by 2 squared to the two terms we have. Our first example, x squared minus 4x. Let's take its b value, which is negative 4. We'll divide it by 2 and square it. That'll be negative 2 squared, which gives us 4. So if we add 4, we'll have a perfect square trinomial. X squared minus 4x plus 4. We'll do the same for y squared plus 9. I'm going to take its b value, which is 9, divide it by 2, and square it. Now 2 does not divide into 9 nicely, and we don't want a decimal here, so we'll keep the fraction. 9 divided by 2 squared, we square the top and square the bottom and get 81 over 4. Our perfect square trinomial is going to be y squared plus 9y plus 81 over 4. What we needed to add to get the perfect square trinomial is 81 over 4. These constructed perfect square trinomials will always factor into the form x plus b divided by 2 quantity squared. With some of the perfect square trinomials, you'll be able to look at it and just factor it into a perfect square trinomial, like this first one, x squared minus 4x plus 4. We could easily find two numbers that multiply together to give us 4 and add together to give us negative 4. But if we look at our other example, y squared plus 9y plus 81 over 4, that one's going to be much more difficult to factor. So you really want to remember that these perfect square trinomials always factor into the form x plus b divided by 2 quantity squared.